We are going to continue with the naming and writing of ionic formulas now. Here are just a couple examples of what ionic formulas are. Notice they all begin with a metal. And how you know that is, if you look on the periodic table, potassium is here, magnesium is here, aluminum is here. They are all on the left of that squiggly line. That tells you immediately that's going to be an ionic compound and you want to follow these rules. So K is potassium, I is iodide, potassium iodide. Mg is magnesium, Br is bromine, magnesium bromide. Al is aluminum, O is oxide, or oxygen, becoming aluminum oxide. So let's see where they get their charges from. Group 1A has a +1 charge. That's the very first row on the periodic table. That's this row here. Group 2A has a +2 charge. They're right here. Aluminum is right here. That's a +3 charge. Notice that how they're lined up. They're the taller groups, and that's how many electrons they have to lose to be like a noble gas. For instance, Li only has to lose 1 to be like helium. Strontium has to lose 2 to be like krypton. And that's how they figured out those charges. Zinc and cadmium are +2, or +2. Those are unique. You might want to actually put +2 on the periodic table. And silver is a +1. Those three things are kind of unique because they're supposed to change charges, but they really don't. So you might want to jot those down. So, when we're naming compounds, identify the cation and the anion. First you want to do is look at the elements. Name the cation by its element name. Name the anion by its element, then drop by the first syllable of the element, drop the rest, and the rest becomes "ide." And we're going to reinforce this over and over again. Write the name of the cation, then the name of the anion. Cation always comes first. So for instance, K2O. Look on your periodic table. K is right here. K is potassium. So, very first step, identify the cation and the anion. K is potassium. O is oxygen. Name the cation by its element name. So we're just going to put potassium. Name the anion by the first syllable. So oxygen, ox is the first syllable. Then we're going to drop the rest and turn the rest to "ide." So oxygen becomes oxide. So name the cation first and then the anion. Potassium's the cation, oxide's the anion. So this is potassium oxide. We can do this again. Ca is calcium. And it's going to take some practice looking on the periodic table to figure out what these elements are. And O is oxygen. Name the cation by its element's name. So that's just calcium. Name the anion by the first syllable of the element. So that's ox. And then drop the rest and put "ide." Calcium's first because it's the cation. Oxide's second because it's the anion. Al is aluminum. O is oxygen. So it becomes aluminum. And then oxide. Mg is magnesium. Cl is chlorine. So that becomes magnesium, just the element name. Chlor is the first syllable, ending in "ide," so chloride. the cation than the anion. Now, writing the formulas we talked about in the previous section. You take the two, you put them together in A plus, Br minus, crisscross the charges in A1, Br1, and you don't have to rewrite the ones, so it's just NaBr. Na plus, S2 minus, crisscross, Na2, S1, don't write the 1. Na plus, N3 minus, crisscross, Na3, N1, but you don't write the 1. Now, aluminum is going to be a little trickier on the very last one, but that's okay. We'll talk about that when we get to it. Al, 3 plus, Br minus, crisscross, it becomes Al1, Br3. Notice I didn't even bother writing the 1 this time. Al3 plus, S2 minus, crisscross, Al2, S3. Once again, I never write the charges, I just write the numbers themselves. And the last one, this is a little trickier. Al3 plus, N3 minus, crisscross, Al3, N3. Notice that they're both divisible by 3. We want it into the lowest number possible, so we can divide both of these by 3. This is something unique to ionic compounds. You wouldn't do this with the other type that we're going to discuss later. But because these are ionic and we're just trying to balance the charges, it doesn't matter if we have 1 of them, 2 of them, or 3 of them. Since they're even, they're going to be balanced. So it's just going to be AlN. We don't have to write those 3's. You want to reduce it. Now there's some that are a little bit more confusing, and those are called transition metals, because those metals change charges. When we were looking at the periodic table, we said this is a +1, this is a +2, this is a +3. We kind of ignored the ones in the middle except for those 3 exceptions. And that's because those charges can change. Because of the fact that the charges change, we need Roman numerals to tell you what the charges would be. For instance, copper could be a +2 or a +1. Iron could be a +2 or a +3. The fact that they change means that we have to tell whoever we're talking to, the other scientists, what the charge is. So if we're looking at here's chromium, here's cobalt, copper, gold, and iron. All of them are in this middle area. Those are the ones that need Roman numerals. Also, these need Roman numerals here too. So let's take a look at this one. Manganese is right here. It's in the middle area. Because of that, we're going to need Roman numerals. But when we're given the compound like this, we have no idea what the Roman numeral is. Well, if you reflect, where did this 2 come from? Remember when we first did this, we crisscrossed the numbers to get these down here. Well, in order to get the charges again, we're going to uncross it. So it's manganese. And because of this 2 here, it's going to have a Roman numeral 2. And then F is fluorine or fluoride. One thing you want to double check, always double check the anion. This is a 1 here, so this should be a -1. Here's fluorine. It's in the -1 row, so that works out. There will be situations where that doesn't work out so nicely. So just to give you a little bit of an overview, here are some of the positive and negatives. Notice that group 1A is always +1. Group 2A, always a +2. Aluminum specifically is a +3. Notice that these in the middle can change. And these here, I mentioned earlier as well. And then when we get back up here to the tall rows, so it's the short rows that you want to be careful of, the tall rows, -3, -2, -1, that's because they have to gain an electron or two to be like a noble gas. So let's take a look at naming compounds with those Roman numerals. Determine the charge of the cation from the anion. That's how we uncross. And then double check. Name the cation and use its Roman numeral. Name the anion with the first syllable and "ide," and then put it all together. So, FeCl2. Fe is somewhere around here on the periodic table. So we have no idea what it is because it's in that short row. So that means we need to uncross these. So the number here is a 1, so it's a -1. The right one is always negative. And here is a 2. So Cl is right here on the periodic table. It's in the -1 row, so that checks out. So we have Fe is iron, +2, use the Roman numeral, and then name the anion with the first syllable. Chlorine becomes chloride, and then put it all together. Let's take a look at this one. Periodic table is right. The iron is here. Oxygen is here. Iron, we have no idea. Oxygen should be a -2. So let's uncross it. Fe becomes a 3. Oxygen becomes a -2. That checks out. So iron, determine the charge of the cation. We determined it to be a 3. Write the name with the Roman numeral. Oxygen becomes ox with "ide" at the end. And then put it together. Sn is right here. It's one of the 2 exceptions outside of the Roman numeral area. And chlorine is right here. It's in the -1 row, so this should have a -1. If we uncross, we have 2 and 1. So that's +2 and -1. So 10, 2, that -1 checks out, so we're okay. Chlorine becomes chloride. And put it together. So writing the formula is reversing this process. Identify the cation and anion. Balance the charges by crisscrossing. And then write the formulas with the cation first and the subscripts. So, chromium is Cr. That 3 tells us it's a +3 charge. It doesn't tell us that there's 3 chromiums. It tells us the charge of the chromium. So it goes on top. And then bromine is bromide with a -1 charge. Crisscross, Cr1, Br3, or just CrBr3. Let's look at some more. Nickel 2, that means that it has a +2 charge. Sulfide, sulfur is right here on the periodic table. It has a -2 charge. Crisscross becomes Ni2S2. Remember before we were talking about the aluminum and nitrogen, how they canceled out? Well, these cancel out too. So it's just NiS. Zinc 2 chloride. Zinc is one of those exceptions that don't change. Zinc is a +2, and that's just a memorization thing. Chloride is right here. It's a -1 because of the row it's in. crisscross, balancing the charges, Zn1 Cl2, or just Zn Cl2. And then finally, iron 3 oxide, that 3 means it's a +3 charge. So Fe +3. Oxide is oxygen, and it's right here, also a -2. Crisscross, Fe2O3 when you balance the charges, and you write in the subscripts. And that is all for naming and writing out the formulas for ionic compounds with transition metals.